when a ray of light is incident parallel to principal axis, it reflects away and appears to pass through focus. Okay, so you will notice that incident and reflected light are on the other side. Again, if it comes appearing through focus, then it is going to reflect and become parallel to the principal axis. It talks about a ray of light that goes through center of curvature, but again, being a mirror, it's not going to let light go through. It's going to bounce back in the same direction, but it will appear as if the light is passing through center of curvature. Alright, so now for this ray diagram, there's just a single ray diagram that we are going to look at for a convex mirror. So first I am going to draw my convex mirror a little large. Okay, same three parts: pole, focus, center of curvature. Pole, focus, center of curvature. Now, like any mirror, the object has to be standing in front of the mirror, right? This is the reflecting side, object is there. Now, I'm going to use only these three rules, and just like we did before, only 3 rays of light we are going to be using to do this, 2 rays of light to be finding the image. Okay. Now for the first, I'm going to use the first rule first. I'm going to send a ray of light parallel from this, right? So this is my incident light. Now once it touches, it reflects back, but in a way that it appears as if it has passed through focus, right? This is my first ray of light. For the second one, I'm going to use the third rule. Okay, I'm going to send a ray of light that appears to be passing through C. Okay, since it comes and goes back in the same direction, I have put 2 arrows, one coming and one going away. Now you'll notice that wherever these dotted lines have extended, those lines have met at a certain point over here, right, somewhere in front of the focus. That is where my image will be formed. This is my object, this is my image. Now if you look at this image closely, you will see that it is much smaller than the image. So if I talk about its properties, I'll say that it is a, in terms of size, it is called a diminished image, meaning it is smaller than the object. If you also see, the arrow is still pointing up, right? So it is also what we call as an erect image, right? So the image is diminished, it is also erect. So these are the two nature and size of the image. One thing we have to keep in mind is, no matter where you put the object, the image is going to be something like that only. So there is only one ray diagram for a convex mirror. One very easy trick for you to remember is, whenever an image comes upright like this, it means that this image cannot actually be seen on a surface. If you remember, we did that experiment with the candle where we were able to see the wick of the candle on the paper, right? All of those images were not erect, they were all upside down, right? So what we call as inverted images. Every inverted image in this case can be captured on a screen, like on the paper, but any image that is upright like this cannot be captured on a screen. Another way to remember is, if the image is behind the mirror, then it cannot be captured on a screen. Okay, this is what we call as a virtual image, right? Virtual image, it simply means it cannot be captured on a screen. It will be visible to our eye, but if you try to put a paper behind the mirror, you will not be able to get that image on the paper. The same virtual image case applies also to one of the cases in concave mirror. If you remember, it will have an upright image that is between F and P. Everything else is called as a real image. Any inverted image that can come on a screen is also called a real image, but this case is a virtual image. So that is it for now. This is about convex mirrors and rules of reflection and a ray diagram for convex mirrors. Okay, so now that we are familiar with the ray diagrams for both of these mirrors, I'm going to tell you about certain names that we call it. So every concave mirror is called as a convergent mirror. By convergent, I mean to say that if you notice, every ray that comes parallel to the principal axis, all parallel rays are going to hit the mirror and converge or meet at one point. They come closer to each other. Along the same lines, every convex mirror is called as a divergent mirror. To diverge means to go away from each other. So if you send parallel rays, you will see anything that goes parallel strikes the mirror and goes away from the mirror, right? And away from other rays also. So every time we talk about concave mirrors, we call them convergent, and convex are called as divergent. So finally, these are a couple of uses of concave mirrors. We will have seen curved mirrors in general in daily life here and there. Maybe we don't recognize them, but now we'll be familiar with a few uses of each convex mirror. So here is a list of certain uses of each curved mirror.